Okay, let's almost 5 after that. Going, I think. Don't see too many other people joining on a regular basis. So, anything, Steve, that you were able to get done further? Any good scores?
I haven't had any scores yet. I'll still be working on the segmentation, but yeah, I've just been struggling again, like with Kaggle data sets. They can be like a complete nightmare to make, just in the fact that like they take absolutely ages. If you've got like a lot of data, it takes ages to like upload the data. Um, and then like even when you upload the data, then you got to press the create button, and half the time, like then it just like sits there. Like after about half an hour, it says, "Oh, it's failed." Um, but I eventually have managed to create all of the data sets I want now, so I think I'm okay. So everything's converted in the same way. So like all of the competition data, like all of the Brat's 2020 segmentation data, and then I got all of this year's task one segmentation data and have converted all that. So I finally got like data sets for everything. So I'm just now in the process of like starting to train the segmentation model. Um, the one I had before, it's using Keras, and like in Keras, I just like taken it from somebody else's notebook, and like what they did was they just sort of stacked some NumPy arrays on top of each other and like made one big massive sort of data set like that. But you've obviously got like sort of memory problems, and you're constrained by how much you can stack together in one go. So like they were only using like 20 images when they were creating their segmentation model, and I wanted to use the whole of the data set. So you have to write in Keras, you have to write a thing called a data generator. Um, and it's quite tricky to write. Um, it's easy enough to write if you just want to like start at the first image, and because I'm doing like 2D slices, I've got to like load an image and then work my way through all the slices of that image and then load up the next one. So I wanted a data generator that would like do random stuff, where it would sort of pick a random image and pick a random slice. So I thought I had that working, and then I'd left it running and it crashed about halfway through, but I think I've just fixed that bug. So it's off running again. So hopefully if this goes through okay, that'll be the segmentation model finished. And then I can like, yeah, like look at the stuff that you guys have sort of been working on, like where you actually sort of take the results of the segmentation thing and like narrow down where the tumor is and then apply the classification. So hopefully I'll get onto that within the next day or so.
Mm-hmm. Yeah, because I think I was just telling Mehul earlier that we did, both he and I tried various 64-bit voxels, 128-bit voxels. I also tried slicing the 128-bit voxels into 64 slices. That didn't give me any better. It kind of about the same range, 0.60 something. My best results of 0.62, I think, was obtained when I just used all of the 128 sized voxels. But even there, you can see from the plots that half the time, or I would say, half the time, maybe 2 out of the 4 MRI types, the model is not learning anything or much, because it starts overfitting at about like the 10th or less than 10, sometimes in the second epoch itself, and then the validation loss begins to increase past that point. But somehow, just because of randomness, because the data is so little, it hits on a higher AUC. But that's where when you ensemble and stuff, you're kind of stuck at around 0.6 something. Because a couple of the MRI types, it does learn, and the the validation loss keeps going down. So the plots are interesting to look at.
Yeah, I have a couple of questions about this. Whichever way we go, like, when eventually we get the segmentation and we do the classification. So what are we, is it that after ensemble, like, we have a validation AUC? Is that the number we are going to trust? Like, I'm asking because I was looking at some stuff and, like how we've been running for 10 epochs, 20 epochs. I saw, because we had to train from scratch. So I started training like 40 epochs and 60 epochs. And it's been a mixed bag. It's like individually the like I have one experiment where individually the 4 models did pretty well. So like each of them is greater than 0.65. I don't know if all 4 reached 0.7 individually. And then like the ensemble is 0.72. I think maybe all 4 reached 0.7, and then the ensemble, but then the submission is really bad. So I'm like, is it?
What is the submission score though?
It's below 0.6. Let me make sure. I'll make a small spreadsheet. Like because
my inclination to answering your question there, Mehul, is in this case at least I would end up trusting the validation AUC, and especially I haven't done this. That's next on my to-do list, is doing a 5-fold. If you can also do a 5-fold and kind of get similar result rather than just, because right now we are just stratified split, but it's a single split.
Right.
The best approach would be to do a 5-fold split, train on each of the 5-fold predict on the thing, and then take I forget now. I take the best model from the 5-folds, and then ideally train that on the entire input. And use that to do the prediction. And then, of course, this is for each of the types, and then you would ensemble all the types. And in that case, I would end up trusting, at least I personally, and I'd like to hear Steve and Siva if they have comments, I personally would trust that more than the 87 or the public data set info, because that info is like limited, right? I mean, for example, in our case, I think we have 582. So 1/5 of that is at least 100, 100 plus. Compared to that, 87 is definitely a smaller number. I mean, maybe not by much, but at least by another 30, 40 examples.
Okay, I see. And so is it fair to say, so best case scenario is like we do our 5-fold, right? And we get like, say, 0.72. And then even when we submit, we get something as close to that, like say 0.71.
I don't know how close or not it would be. My, in a few cases, it's been like off by, the few cases I've tried, if it's the best you get is 0.6 in the result, it's a little bit less than that when you ensemble and submit. So, it's somewhere it's not better than the best result, but it's not worse than the worst result either. Somewhere in the middle.
I see. Okay.
So in your case, when you mentioned the results, is it worse than the worst MRI type results?
I need to check that. I remember the one. So the
Because in
best
my case, it was bang in the middle.
bang. Okay. I had one
Meaning not
case.
exactly. By that, I
Uh-huh.
don't mean exactly, but somewhere in the middle.
Okay. One thing that that seemed to help me is like, like you're saying earlier, right? Like there's too much noise and very little data. So I was looking and I saw like okay, this is not, I mean, yeah, the ideal approach is the segmentation, but what I did is I just said, okay, I know the tumor is not in the top of the brain or the bottom of the brain. It's mostly in somewhere in the middle. Um, but just by looking at some of the images, so suppose I had 128. So then I chopped off the top 32 and the bottom 32, and I just kept 64. And in that case, the T1 weighted contrast image model like learned a lot. Like it went from 0.55 to zero point 0.7. Like with lesser data, like with lesser slices, the model could learn. I'll make a Google Doc with the summaries. I have like a
Yeah.
couple
Now,
of.
when you say the one thing which I kind of when you say you chop, did you chop in all directions, or
No,
did you
only
just chop the depth?
only Z. Yeah. Yeah, only
So is Z the first dimension or the last?
the last. Wait, did I chop the right then? I need to look now.
Yeah, because that's where I was confused. So I ended up doing both just to see which,
Okay.
because I wasn't 100% sure whether it was the first or the last.
Okay, I thought he oriented in axial, so I thought the first was like axial. So, wait, I need to go and check now. Oh, crap. I should just visualize some
Yeah,
images.
so because of
Yeah.
that confusion, I wasn't 100% able to like screw it. I'll just do it both ways. So
Yeah.
I did it, and it didn't. I mean, it might have individual components might have improved, but that's where I did try that same thing that you did, but my results for that were the ensemble was slightly lower than the 0.62, but that again might just have been an accident.
Yeah.
It was in the 0.60, 0.61 range.
Okay. What do you guys
So
think?
yeah,
Like,
if you figure that out, let me know
okay,
which
yeah,
one it is, the first or the last.
okay, I'll try and look at that. I have one question. So I have couple of submissions where like the validation ensemble is 0.7, but then the submission is 0.55. Is it just means it's learned? I don't know how to interpret. Is so? I was thinking this is like a trash model then, if that gap is so big between the. What do you guys think? Like, or,
It is strange, isn't it? It's like
yeah,
and when your model's training, is it sort of the validation score staying sort of similar across each epoch, or is it like bounce up and down a lot?
yeah, there is some bouncing. Yeah, maybe.
Yeah,
No, I think invariably what I saw was a lot of bounce.
Yeah.
yeah. So like that's sort of what I've seen as well. So perhaps it's just that model isn't very good with the public data set or whatever.
Okay. Yeah, the best I got so far is like I took your 120, your notebook the 128 notebook, and I chopped off slices, and I think the best I got was 0.633 on the public. And there at least it was validation was 0.7, and then on the public test set was 0.633. But I have a lot of, I'll get excited by looking at the validation score. I'll be like, oh, 0.73. And then the submission is like 0.57. Like, what?
Yeah, no, I think at least what I've done is that's where, you did us all a favor by adding the plots, because the plots tell you in which case you just lucked out.
Mm.
So the 0.7 or whatever, if you see, could very well have been from AUC just bouncing around like crazy, and you just caught a lucky point. That's not going to generalize.
Okay, I see.
So you see in some cases, the AUC is just bouncing like crazy. And then the 20th or the 19th episode or epoch, you get like a really good value. And that's obviously because we are picking based on the best AUC, we get a really good number, which is probably why, to a certain extent, and I haven't tried this, but now I can kind of appreciate why, way back the original guy picked based on the validation loss, which obviously, if you just pick on the AUC keeps bouncing up and down even after the validation loss has begun to go up, and you pick an AUC, much later if it happens to be good. Now, if you pick based on the loss, you'll pick the validation loss that's lowest. In all cases, I do observe the training loss continuing to go down. But if you pick based on the lowest validation loss, then again, I don't know whether that choice would be a better choice from a generalization perspective. That's a question. Do you have any comments or thoughts on that, Steve?
As you say,
picking...
in the original notebook, yeah, so like he was like saving the model originally by the AUC score, and then in the notebook you'd like noticed that he'd changed to using the loss, and yeah, in the comments of it, he'd sort of like left the thing in saying save the best AUC, and then like somebody'd asked him like why he'd changed to like save from the validation loss instead of the AUC, and yeah, he'd said that yeah, like that's what he was saying, that it was like sort of a bit unreliable, and it was better. He was getting better results using the validation loss.
Okay.
To save the best model.
I see.
So that might be something we may. I'll try it, and Mehul, especially if you're building a spreadsheet, you may want to fill it out as it is right now, and then do it with the loss and compare, because that might give us a good indication of what's the better choice there.
Yeah, that's a good idea.
Or what generalizes better.
I had one more thing I thought that might help is it's more like about the images themselves. So we have these two types of images, right? Like the T1 weighted and the T1 weighted contrast enhanced. So the T1 weighted is like a pure structural image. Okay, so it just it gives you like really good structural information, and okay, this is the brainstem, this is the hippocampus. It's very clear. Okay, so the contrast enhanced one is very interesting. It's like they always do the T1 weighted first. Okay, and then they will inject like a contrast agent in the patient's body. Okay, and within 5 minutes that contrast agent it circulates in the bloodstream and reaches the brain. Okay, the interesting part is it cannot, like, so suppose if they put that contrast agent in you and me, it will not enter anywhere in the brain. And so they inject the agent and then they take the MRI. That's the T1 weighted contrast enhanced image. So our normal people MRIs, that will not show up. Only when people have these brain tumors, or there's another disease called multiple sclerosis, where it's kind of like somebody's made holes in the brain. That's where this contrast agent gets in. So this contrast agent gets into the tumors. Yeah. So initially I thought, that the T1 contrast agent model should be the best, like among the 4 individual models. But for a long time it was not. It was always like T2 or flare or something else was better than the T1 contrast. I was expecting this one to be the best, just because it actually has that localization that that okay, the Okay, the contrast agent got in, so you can start seeing the boundaries of the tumor with the contrast agent image, and then that's what they use it for too. That's how the doctor. So the agent gets in, so it's like very easy to see. Like, oh, Mehul can see the brain tumor too, you know. But but until I chopped off slices, the T1 contrast agent model was not learning at all. It was always like, and Srinivas, you might see that in your notebooks, in your runs too. Like the T1 contrast in the individual model is like always 0.55 or 0.6. But after you chop off slices, it started getting a little better. But I just wanted to share that.
Yeah, when I'm doing the segmentation at the minute, I'm just using the flare images.
Flare. Okay.
But yeah, like it was just to get up and running. But like
Mhm.
maybe it was just, yeah, the flare ones looked sort of brighter, and the tumors, yeah, from just looking at them looked like it sort of they stood out better. But yeah, like do you think the contrast ones then would be better to identify the tumors from?
I think so, but I can check like what they did in last year's Bratz
Yeah.
segmentation. I know some people say like they call it like multimodal segmentation. So they'll try to use like flare and T1 the T1 contrast image to T1 weighted contrast to do the segmentation. Um, but I'll check and like get back. But I think flare
But
should be good too. Yeah.
but if you did any multimodal stuff, then you would need to for sure
Yeah, that's
do this
registration.
the atlas thing, right?
Right.
Yeah, because you would need to synchronize the two and align them perfectly.
Yeah.
I think flare is good. Yeah, it should be. And once you have your maps, we can do a comparison like how it looks between like just putting the segmentation output from the flare. Oh, okay, line up. We still have the lining up. You have all of them like in. Do you register all of them for a patient, like not to the atlas, but just to the same?
Yeah, I do, but yeah, the trouble was I'm saving like the NumPy arrays, and it was just it was just ending up with too big for the Kaggle data sets again. So
Okay.
I just had to restrict it to Flare for now to get things up and running.
Yeah, that.
But yeah, like once I've sort of got this working, then I can sort of try and create separate data sets for the other 3 types, and then I can like run all 4.
Okay.
But yeah, as I say, I just needed something sort of. It doesn't need to be perfect, the segmentation model. It just needs to sort of hone in on where the tumor is, and then like do sort of the type of stuff that you guys are doing, but like just with small cubes or whatever, but where the tumor is. So like I don't need to sort of 100% accurately identify every pixel of the tumor. I just need to get the sort of the basic region for where it exists.
Yeah, in fact, actually, if you can even get as an earlier notebook you had shared, Steve, did the slice with the largest pixel content, even that, whatever the height and width be, don't care. But the depth at which the pixels are the max, and you just can, if it can just even do that itself ought to be a really good input to the classification model. I mean, the expectation then would be, from what Mehul and I have been dabbling with, that such a model or such an input to the classification ought to dramatically increase the classification predictability. But we'll see.
Yeah, that's what I thought. And yeah, like that was going to be sort of, yeah, the first step was, yeah, just identify the slices where the tumor is and drop the ones where there's no tumor. And then, yeah, like narrow it down to just the tumor as opposed to the whole slice.
Right. But actually, the thing there, though, that I think I mentioned it previously too, but you would have to pick the broadest or the thickest or the thinnest value, right? Because the point is, I don't know that you can. Well, actually, you could potentially give. What I'm thinking about is your input sizes. By that I mean, the dimensions of your voxel input to your classifier would have to be all of the same shape for them to be able to be patched. So you can't go to the extent of each patient's tumor dimensions, because then each of the thickness dimensions will vary. You see what I'm saying?
Yeah.
Whereas in order to batch, you would need, like, the shape of the voxel. Just like you can't batch a 2D, which is different in the two dimensions for an image, for a 2D image, right? Like it has to be, if one image is 128 by 256, all the images that you're batching have to be 128 by 256.
Yes, like there you've probably got
You
two
can't
choices,
have
don't you?
one.
You can
Sorry.
So if it was just like, as you say, like a 2D image, yeah, so like if I'm just taking like a 2D slice and I've identified where the tumor is, and yeah, so like as you say, for each patient and for each slice, that bounding rectangle is going to be a different shape and size. So yeah, like I thought you would have two choices. You could either resize it, like stretch it or shrink it, so as you always have the same size, or else you could chop it up into tiles, or in the 3D case, chop it up to cubes or whatever. So
Yeah, that's where I was thinking that the easiest thing to try would be to keep the, and again, this is where it depends on how the segmentation voxels have been created, right? If already during segmentation, if you're trained on 64 size voxels or 128 size voxels, then just a matter of getting it. But if not, then keep the H and the W constant and then just pick the min slices for which you find a tumor and make that the same for all, rather than a more complex approach where you identify the tumor dimensions and then try to create one of the two approaches that you are describing.
yeah. I just had a question for you, Mehul. You said that you're training your model from scratch. The stuff you were showing us last week, I can't remember the name of whatever library it was. Do they not have pre-trained medical classifiers?
No, they don't have pre-trained dense nets.
You've become very quiet.
They don't have pre-trained dense nets.
Mehul, something wrong with your speaker.
Can you hear me now?
Yeah, it's better. Yeah.
Yes, much better.
It's better. Okay. Yeah. Sorry, my speaker. Yeah, they don't have 3D pre-trained. They have 2D pre. And that is one thing I was
All right.
looking at.
Sorry, I remember that. Yeah, last week you said, yeah.
Yeah, we were, and I found one person. They have like a pre. It's called Tencent. There's a company Tencent, and like they have a GitHub repo for Tencent 3D medical. and they had some pre-trained models. That's the only one I found so far. But I haven't. I think they had an example. Oh, I should just share that link, because they were like, okay, this is how you would use a ResNet 18 and do the segmentation with our pre-trained model.
Yeah, I thought the model that they had pre-trained was a segmentation model, not a classification model, if I recall correctly.
Yeah, that's right. So, but can we use that? Maybe just maybe some of the. Is there any way to use like part of that model? Or no? I don't know. Like just take, like the first 5 convolution layers, or take. Like sorry, go ahead.
No, I had seen that. Let me see whether I can find it. Oh, yeah, at the link. Let me see whether I can.
I think
about the same.
Okay.
Yeah, I think Sevram and I posted the same link. Is that the one, Mehul, that you're talking of?
Yes, that's the one. Yeah, I think they even have a archive paper for like transfer learning in medical imaging, and yeah, that's where I saw. That's and they show some 3D segmentation that with and without transfer learning, how it looks.
Yeah, it's much better, but it's a segmentation model. I don't know. I haven't read it. Maybe you have to read the paper to see whether we can modify it to do classification.
Has it been pre-trained on the brain, or has it been pre-trained on lungs?
I think brain. Yeah.
Oh, really?
Well,
because here they show lungs.
Oh, really? Okay, maybe.
It looks like pictures of lungs, and
yeah,
like it says at their top, pre-trained, and then it says lung segmentation.
It
says the dice score that they're getting on the lungs.
I see. I think here, because in where did I see the brain segmentation images? Yeah, if you just scroll down, and under performance, you see the ground truth and the medical net and train from scratch. Wait, what is this structures now? I thought it was the brain. Maybe not.
Maybe your brain's a funny shape.
No, but it's like if you only segment certain things in the brain, okay, maybe what is this? What are they showing? God damn it. Yeah, because in the acknowledgement, they say, we thank 3D ResNet PyTorch and MR Brains S18, which we build medical net, blah blah blah, and that MR Brains is from some other competition, some like brain segmentation competition.
Yeah.
But let me check. I can check the paper, and I did look at that paper before. Blah blah.
Yeah, even those images are of, they clearly say results of transfer medical net pre-trained models to lung segmentation and pulmonary nodule classification with
Okay.
DICE and accuracy evaluation metrics respectively.
Okay. Yeah.
So the nodule part, which seems to say that they have somehow also done a classification. Whether they use the same model to do the nodule classification, pulmonary nodule. So this might be the equivalent of doing the MGMT, right? Like once you segment the lung thing, then you go in and do this nodule classification. Right? Like after you have segmented something in the lung, then you go in and look at whether that has whatever nodule related something or the other, which then needs to be classified.
Okay. I'm just going to quickly check if there's any, I thought, pre-trained.
The only other place I saw pre-trained is in that NVIDIA something or the other. I forget what they were doing. You had also referred to it earlier, right? I forget what that.
No, not Monai, right? Something else. Yeah.
Was it Monai itself? It could have been Monai itself. Because NVIDIA is doing the Monai, right?
Yeah, NVIDIA is doing.
They have some models. Hello.
Yeah.
So, any other thoughts?
I haven't looked at the discussions or the code that people have been posting this week. Has anybody had a chance to look at those? Has there been anything interesting? Or I saw somebody put a notebook in. It was, you know, like what do you call it, YOLO V5, which is
really?
Yeah, so like sort of like doing the segmentation using YOLO thing. But I only sort of glanced at it. But
No,
yeah,
I think I see. No, I didn't see that one. The most interesting one I thought there's one called Torch.io. Like it's somebody. I think that guy is building like a library for like medical images. He's at University College London, or like he's a PhD student, and so he's built. He had a nice notebook with just showing like some how you can do pre-processing with his um, with that library, and yeah, that's the one. I think it's got a couple of stars and likes. Yeah.
was that the one you were showing us last week? It's got like all of the augmentation features.
No, no, the augmentation is part of Monai. So in the notebook, Srinivas and I, we are running. We have put in like a bunch of Monai augmentations like Gaussian noise and random noise and some random. But his, I think he might have. I don't know if he had special or he might have augmentations too. Yeah. He, like he made a special class for RSNA dataset and to just make it easier to do like registration to Atlas and that those steps. That notebook was nice, I thought. And yeah, I think because we end up writing a lot of boilerplate code, right, with just with plain PyTorch. So um, Monai officially says that okay, they can combine with Ignite, something which reduces the amount of boilerplate code. And there's another library, I think PyTorch Lightning, with the same idea that you don't have to write so much boilerplate training code. So um, I think the Torch.io guy then says that okay, you can use Torch.io, Monai, and PyTorch Lightning. So that's the I, but he doesn't do it exactly, but he just say okay, now you can first pre-process through Torch.io and then pass it on to one of any other libraries. Yeah.
Actually,
Also,
I haven't done it, but eventually all those lead to, you could use Fast AI, and Fast AI is just a nice superset of all of these different things.
Yeah, that's
Each
true.
of them just takes incremental steps towards where Fast AI already is,
I see.
if you're familiar with it. So
Yeah, no, that's a good point. Yeah.
the only thing that puts me off Fast AI is, yeah, like it does like an awful lot of stuff for you and gets rid of like a lot of boilerplate, but at the same time, it does a lot of stuff that you don't really know what it's doing. Um, that's sort of like why I just went back to basic PyTorch, because like then you sort of have control over every step. Whereas, yeah, like I know, like sort of Fast AI, when you were doing image things and stuff, it was choosing values for you and choosing augmentations and things. But I've
yeah,
played it.
that's something I agree, Steve, with what you're saying, because that's something which tends to make me mad too, because sometimes it hides things to abstract things away, but then when you're trying to deal with multiple things, you don't know what it has under the hood done.
Yeah. I've played with the PyTorch Lightning as well, and as you say, it is basically just a sort of a copy of Fast AI or whatever. But yeah, like I liked it. I thought it was good. But yeah, like so, like there you were saying, Mehul, that this guy is like saying to use his, what's it called, Torch.io and Monai together. Well, I thought Monai and the other one you were talking about were just sort of similar things. What's the difference between the two of them?
So Monai is created for like for it's like a general purpose medical imaging deep learning library. So it has functions for like you can do they built on top of PyTorch, um, and they like you can do like say medical segmentation classification. It has the Nifty support. Um, so, but it doesn't have so Torch.io has like the things like registration to an atlas, right? Um, that part is missing to in Torch.io. There are some overlaps, but um, so Mona is from NVIDIA, right? So they have some uh, like they are like okay, so on the GPU, if you want to maximize your performance, they talk about like cache data sets and persistent data sets, which like the IO guy doesn't know, right? Like he's just focused on okay that what could be some pre-processing steps in medical imaging that could be useful, right? Um, I'm actually like from work. There's a Monai boot camp, and like me and my friend, we are going to it next week. But I think all they're going to record all the sessions and release them on YouTube. It's like a 2-day mini camp, like like 4 hours on Wednesday and then 4 hours on Thursday.
All right. Are you
So
actually
I
going
should,
to it physically?
no, just an online site.
Oh, right.
Yeah. And yeah, I think so. What they have been doing is there are too many of these packages, right? And then everybody is doing the same thing. Read Nifty, do. Mm, and so they're saying, okay, let's try and like just um, have one easy standardized package for medical imaging. And there was, because all the stuff with DICOM, right? Reading DICOM images, it's just like, okay, you need to know how this standard works, and okay, what is axial, coronal, sagittal, blah blah. What though do they? But that now I need to check if they have like Nifty support or not. Then all the like 3D transformations, like they have so many augmentations, and I will try and find out more information, like why they think they need, like why couldn't they just have done albumations or like other augmentation libraries, because they've implemented the augmentations themselves. Maybe they think it's needed for 3D. That's my guess, but I will check with them. Yeah.
All right.
Yeah. But I think those are the main things people are using, like Torch.io or oh yeah, one thing was very interesting. I think somebody figured out how to use TPUs for the training.
All right. Was that PyTorch or was it Keras?
With Keras, yeah.
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 PyTorch seems to struggle with TPUs.
Yeah. Uh-huh. Yeah. Hey, just sorry, somebody's come to like deliver some stuff. Yeah, I'll try and come back in.
Okay.
Hello.
Were you speaking there? I couldn't hear you. Are you on your phone?
Yeah, why?
Oh, because it just popped up with a big phone icon for you.
Oh, huh.
But,
Yeah, something strange happening with my internet connection. I've been trying to log in, but it just kicked me out for some reason.
you're in twice now, yeah.
Yeah, it's trying. I'm already logged in and it booted me out. So I don't know what's going on. Some weird stuff happening. Yeah, I haven't looked at any of the recent posts. That's a good point. I should probably check any interesting.
Yeah, I tend to like try and sort of stay on top of the discussion ones, because like quite often, yeah, like when things are happening or whatever, people are putting them in, like all the stuff about people doing their leaderboard probing and getting completely accurate scores and stuff. There was like big discussions on that and talk about sort of would the organizers like release the public data set, because it's a bit unfair if people have that information, because they've obviously they can like get at least 20% of their data set completely right.
Yeah. Yeah, it's kind of crazy, but because the kind of defeats the whole purpose of trying to use this for really trying for the greater good of being able to identify something useful rather than just get the highest score in Kaggle.
Yeah, although I suppose, yeah, you might get that 20% right, and then the actual sort of the private test set, you might get every single one of them wrong. But it means like they've got like 20% more data to train on.
Yeah. Yeah, I haven't looked at that recently. That'd be a good thing to scan again. And where did you say you got the segmentation model, Steve? You got it. I tried to register, in fact, for the Bratch 21 competition, and I don't know, it's really weird. I think the Synapse guys or whoever was running it fell asleep at the switch, and like I registered 3 weeks before, sent them 3 reminders, and yesterday, like I don't know, maybe a week, even after the deadline has passed, they said, "Oh, now you can go and do this," and I'm like, "Thanks, guys."
Oh, right. Had you not been able to get the task 1 data before that?
Yeah, I wasn't even able to get access.
Oh, actually, the task 1 data is now up. Somebody's taken it and made a data set from it.
Oh, okay. I didn't know that.
Yeah, in a sec, I'll just find the link to it. Yeah, because I can't remember if I used it or not, but yeah, because like I registered for the task 1 competition, and like I was like able to download their stuff, and like yeah, somebody published a notebook as well, sort of showing you how to like download, but you had to be registered, whereas
Right.
I think
And that's where I tried, I registered, but it wouldn't like that after registration, they are supposed to approve your access to the data, and that didn't happen for me until yesterday.
They look as if they're having like a lot of problems with their task 1 competition as well. Yeah, like I've had emails from them, like, and they've been saying that they keep on sort of extending the deadline, and like now they said that the GPU on their system or whatever wasn't like sort of powerful enough to process the thing, so they've put a whole new system up for people to use.
Yeah, I saw that message too.
Hi Steve, I sent some link in the chat. Is this the dataset you're referring to?
I've just found it now, so let me see.
Okay.
It's by the same person. I say I've just found the one. So is that one there? I think. Yeah. So like that's the complete task 1 data, like all the nifty files tarred up.
And one more thing, I also experienced the same problem while uploading like 10 GB or 20 GB data set. It will upload, and after while creating, you will get some error. And I also submitted some discussion, and some guy, he's a grandmaster in competition category. He pointed out like we can just add a password to the zip files, such that when they are trying to create, it will not create. It will just be an zip file. Then after that, we can just import the data set. Then we can unzip, and then you can use. He said something like that. I haven't tried it yet, but you should try. He said like some other people also commented that it will work.
Yeah, yeah, because like that's the problem. It's like if I upload like a 1 GB zip file that contains, say, 10 gigabytes of data. As you say, like their data set mechanism tries to unzip it when you upload it, and so like suddenly you run out of space because it's doing that. So yeah, I think that's maybe why like this guy here has uploaded them like as tar files. It maybe doesn't untar them, and so it keeps them as tar files. And as you say, like then in your notebook you can untar it or unzip it. Um, the last data set there that I created as well, maybe it's just because I've got like loads of data sets from other Kaggle competitions, and I've sort of reached my my limit. It was like saying I'd run out of space. So I had to. You can make the data sets either private or public. So I had to make the last data set public, which isn't it's not a problem, like, but yeah, in the public one, because I hadn't generated any public data sets before, I had 100 gigabytes of space there. So that's one thing to be aware of. If you are running out of space, make the thing public, and then you can have loads of space.
Yeah. Okay.
Yeah, they just want a shared thing rather than just for yourself. That's a good motivation to make things public.
Yeah, although, yeah, like obviously, yeah, like it's fine for me. I can't see anybody else really having much use for my data sets because of the fact that you need to have the code that generated it to sort of deal with things at inference time. But so sorry, how do you say your name? Is it Sivarama?
It's just Shiva. Like I in registered, my full name is Sivarama Krishnan. People call me Shiva.
Call you what? Sorry.
Shiva. SIV. Only first 4 letters. Shiva.
All right. I was just wondering, had you actually made any submissions or notebooks or anything then?
No, I try to make some submission. Then, like all the class, I try to train a single model, and like while you're seeing the validation graph, it was going ups and downs and so many things. Then for the last 1 or 2 weeks, I tried to make a segmentation submission, but I was like in some interviews and also I couldn't concentrate properly. This week I will just try to do one perfect submission, one submission.
Right.
And for like our current one minute. Okay, okay, how can we make that? Yes. Our current flow would be like this only, right? Similar to the like if I like and we mentioned like first we should segment, then we should do an classification. Similar to this.
Yeah.
Yeah. And also like in Monet also I have found out some not only found out some segmentation model for like classifying into the brain images. Did anyone try it similar to that?
What's your question, Siva?
Yeah, like in the Monet, there is an like a segmentation, 3D segmentation model for the brain data set. But I just asked like, did anyone use this or use Monet for doing some segmentation? I was just asking a question regarding that.
Yeah, no, I don't think I have tried segmenting with the Monet model.
Yeah, that's probably a good thing to try. The segmentation I'm doing, it was just from a notebook I'd found, and it segments on sort of the 2D slices. It's not doing 3D segmentation. So yeah, that segmenter might be better.
Yeah, okay. Okay, that's it. I just want to answer something.
So, what data are you training on, Steve, for the training the segmenter on?
Well, originally I was training it on the BRATS 2020 data. But like as I say, now I've got all of the BRATS 2021 task 1 data all uploaded and like all converted into the same format as all my other stuff. So yeah, this week I'm just gonna yeah, try and train on every bit of data I've got for the segmentation stuff, just to create the best segmenter I can create. So yeah, I've got the entire lot.
And they are all flipped and rearranged.
Yeah.
To be aligned.
Yeah. So yeah, so like I've cut off all the sort of padding outside of the brain, so it's yeah, like and everything's changed into the same axes or whatever. Yeah, because like that's one thing I was thinking. It's like, as I say, like I'm doing 2D segmentation. So like I'm just going through, I think, like the axial plane, like taking a slice at a time. But I could obviously do it in the other two planes as well. So like if I did it in all three planes, then in theory, the bits where it says that the tumor is should like align up for each of the. If I did like three models, like each of the models should like align up for and give me a more accurate result for where the tumor is. So I was thinking of maybe trying that as well if I've got the time.
Yeah, the only problem with that is that you could try it offline and not use it in your final flow if you can figure out a way to do that, because using it in the final process is a problem because of the time it takes to align. Right? I think that's what we decided when Mehul was doing it, if I recall correctly, or am I wrong?
Yeah, it shouldn't take too long because it's like, yeah, so I just like stick it through the model and it predicts where the tumor is. That doesn't take too long because it's like a pre-trained model. So like if I have a pre-trained model for each of the axes, then yeah, like that just gives me a 3D NumPy array for each of the axes. So I just need to plus as well, all my images are cubes. They're all 240 by 240 by 240. So I don't think it's like that hard just to rotate a NumPy 3D array. But
Okay. That's what you're talking about. Not when you say align, I was mistaking it to this. So you're talking about aligning per patient the three MRI types and aligning them per patient.
Yeah, so right? at the minute I'm only
as
using.
Opposed to, go ahead. Sorry.
At the minute, yeah, I'm just using like the FLAIR MRI scans. So my segmentation model, yeah, so like for one particular patient, for one FLAIR DICOM file, I've converted that into a 3-dimensional square NumPy array. And then I'm going through like one slice at a time in the axial plane. Yeah, doing the segmentation on that, but I could also, and so like that gives me a prediction for each slice, a 2D prediction, and then I can stick those together to make like the full prediction for the brain. But yeah, so like that's from the axial point of view, but I could do it like by training the model in the other two axes, like either the coronal or the sagittal one. But yeah, it's only using one MRI type at the minute. The other thing I was wondering was, yeah, like now, like in this task 2 competition, it like seems to be like a subset of task 1. It seems to be like task 1 has like way more images, but there seems to be, yeah, like task 2 has just been taken from those. Yeah, so I was wondering if I
mostly.
Yeah, like now I've got the task 1 stuff converted into exactly the same format as I'm using for task 2. I was wondering, like, when we actually submit this for like the private or the public test set, will they also sort of be from these task 1 images? Like it may be that the images that they have in their private task 2 data are exactly the same as what was in the task 1 training set, in which case then my model should be sort of nearly perfect for its segmentation because of the fact it's seen that image already. So
yeah, that's kind of what I was saying a couple of meetings earlier, that actually if, in your case, you're kind of right now predicting for, for at least task 2, you're predicting all the, for at least for segmenting, you're doing prediction for all of the images, correct?
yes.
Right? You're not kind of using ground truth segmentation, whereas the reality is that you have the ground truth data for mostly, I think there are 8 exceptions or 1 exception, I forget which is which, but somewhere between 1 and 8 exceptions. But barring that, you have actually the ground truth mass for all those. And as you're pointing out, you may, if the data is the same, then you may actually be having the ground truth data for the test thing as well. Or that's kind of what you're stating, right?
That's right, yeah. So like hopefully it'll have been trained on images from task 1 that appear in the task 2 actual private test set.
Yeah. Which is why I was saying that I don't know whether there is an easy way to do it, because your way right now is easier, I think, but because of all this data conversion gobbledygook. But otherwise, it would be interesting to, if we can actually use the ground truth segmentation data provided by them in task 1 for task 2. But where we run into that, because that's, or I don't know, maybe even just calibrate your, you could compare your predictions that your model makes on the task 1 data for our competition. If you don't train it on that and train it on everything else, you can then compare the output that you're getting from your segmentation model on task 2 data with the ground truth provided in the task 1 information.
Yeah, I think I'm with you.
I mean, it seems weird, but because you have the ground truth, but your approach of predicting for our task 2 on the data is actually a simpler one. But to get an understanding of how good it is, you could compare it to the ground truth availability from task 1.
Oh yeah. I've started doing that already. So.
Okay, that's cool. How do you do it?
Well, yeah. So like because the images match up, so I was like sticking like the task 2 image through my model, and then see what segmentation it comes out with, and then because I have like the actual ground truth for that image, because it's in like in the task 1 data set as a segmentation model, then I can compare and like see. And like like that was just the model that was
so
trained.
Do you
on the
visually do it, or do you just compare the mask of?
At the minute I was just visually doing it, but I can run like your dice score, the score that tells you like how good it is, like a prediction. So
oh yeah,
so
cool. That's very cool.
Yeah, so like hopefully next week I should have all of this finished. Yeah, so
that's very cool that if you can compare your predictions and get a good reading of the goodness of your prediction model. And as you're saying, it may be, I think it's entirely likely that the task 2 test set is made up of task 1 data that they haven't released for task 2, and is not available as part of task 2. If that's indeed the case, then like you say, your model ought to be really very good at that.
Yeah, like hopefully that's what I suspect will be the case. So yeah, hopefully it should sort of be able to like predict it really well.
Yeah, because in this, at least from what little I have read, it seems like getting data is the big problem in medical image processing and stuff, right? Like, and get not just getting good enough quantity of data, and then the second problem you run into is every data you get is from a different machine and done differently, and therefore trying to quote normalize or get it in the same status. As you said, it becomes more of a data analyzing problem than really a machine learning.
Yeah, like exactly.
Problem.
Like up until now, all I've done is mess about with NumPy arrays and shifting them about and stuff. I haven't actually done any machine learning yet, so
yeah.
Hopefully I've finished that bit though. Yeah, like as you say as well. Do you know the paper I shared like a while back, showing somebody that had done like a similar approach on the MGMT thing? It was like the actual paper that showed they were doing the segmentation and the classification. Yeah, like they mentioned some other, like the data set that they'd used, which was like MGMT data. I haven't actually looked for it yet because like obviously here we've got like a very limited set to train on. So I was wondering, was it possible to get that data set that they'd used, and would it give us more examples to train on?
I'll make a note. I'll at least read. I haven't read any. Unfortunately, you pointed to the paper and even the Mehul paper. I'll at least glance through them and see whether usually somebody or the other on the competition, and this will make me go through the the discussions and maybe the code. Somebody or the other usually posts external data and how to combine it or how to access it. And I saw it when I started, but after that I haven't seen it. So it may be a good thing to go to.
Yeah, there is a discussion thread on it.
See whether I can find the data.
Yep. Yeah, like that paper as well that I'd posted. It's got like sort of like the basic architecture and sort of like their results and like a mention of where they got their MGMT data from. But actually on the website, there's a sort of supplementary thing which has a much more accurate picture of the architecture they'd used. Like it shows the thing in detail. So yeah, it's worth looking at that as well as looking at the paper itself.
Oh, okay, thanks. I'll check that out. Okay, cool. And just more stuff to do. But yeah, I am hoping your segmentation work turns out to be really what makes all of the difference, because I think whatever Mehul and I have been dabbling with seems to suggest that without that, you're kind of just drowning in a lot of noise. And you're not really extracting. And as Mehul said in one of the comments, I also spent a little bit of time understanding AUC better, because periodically I kind of forget all this, which end is up in this whole classification and FP and TP and all this. So I kind of spent some time re-familiarizing myself with AUC. And as he says, anything below 0.5 says you're actually predicting the opposite of what is indeed the case. But that's to be expected, as you have mentioned, Steve, before, when you're that close to like a 0.5. I mean, just by probability, you end up on the other side of 0.5, which basically means you predict negative and positive and positive and negative. So.
Yeah.
So 0.6 something says you're just marginally better than chance. And in fact, for this particular data set, as you showed, like I think you mentioned 0.64 or something, if you just randomly pick, you ought to be able to get to that, right?
Yep.
But the models aren't even getting to that level, which means they aren't much good at all right now in an absolute sense.
Yeah, so hopefully if we can focus in on where the tumor is, then hopefully they'll start learning a bit better.
Yeah. That better be the case, or else we are hopelessly lost.
Yeah.
But it has to be. I mean, otherwise it makes no sense. Otherwise, the answer is, well, unable to predict. But that's where the question for you, the paper you read that was able to successfully predict, do you know whether the result was that they were able to, and about what ballpark results they got in the MGMT paper you were referring to?
Yeah, they were, and like they said, that their sort of model beat all the sort of the current methods for predicting MGMT. I haven't. It's a long time since I read the paper, but I have a feeling they were like, it's sort of like about 0.88 on the
oh wow,
AUC thing. I think that's what
it
was.
That's pretty good.
Yeah.
Yeah, even anything 0.8, and 0.88 is almost 0.9. So that's pretty exceptionally good, because all you're doing is, the whole purpose of it is to avoid all the physical things you have to do when you have to take some tissue from the brain and, drill into a patient's head through the skull, and you avoid all that crap if you're 0.9 good with this approach, right?
Yeah.
That's phenomenal. That means there's a huge gap between where we are right now, 0.6 and 0.88.
Yeah, like at the minute, the scores we're sort of getting don't look much better than you would get with random. So I think we need to hit sort of 0.7 or whatever to be above random.
Yeah, at least.
Yeah.
0.6 high or 0.7. Yeah. Okie dokie. Bunch of work to do.
Yep. Should we leave it there, and I'll go off and do some more work?
Yeah. We'll sync up next week again. Thanks, Siva. Thanks, Steve.
Cool. Speak to you next week then.
We'll be back.
Thanks, everyone.
Yep. Talk to you then.
See you later.
Bye.
Bye.
Bye.